Hello everyone and welcome back to Pharmawise. Today's video is all about chemical bonds. So we are planning to discuss how a chemical bond is formed, what are the different types of a chemical bond, like how an ionic bond is formed, how a covalent bond is formed, and what are the different types of covalent bonds, like how a sigma bond is formed and what are the basis of formation for a pi bond. So this is going to be a very informative video, so make sure you stay till the end so that you won't miss on any of the important concepts, because this is what will build your base for learning the other organic chemistry concepts like hybridization or resonance, etc. So basically you need to understand how a chemical bond is formed, and to know that you first imagine an atom, a structure of atom. We have discussed structure of atoms so many times. I will link the videos in the I button and as well as in the description below. You definitely check those videos out, where I have discussed the history of atomic structure, how an atom looks like, what are the models of atom. We have discussed that in great depth, so do check it out. I will mention the videos in the description. So coming back, this is the structure of atom. So here we know that in the nucleus there is a positive charge concentrated, and around the nucleus all the electrons are revolving, and we know that electrons are having negative charge. So this is how the cloud of electrons will look like. Now this is an isolated atom, a single atom. Now imagine another isolated atom, again positive charge in the nucleus and the negatively charged electrons are revolving around the nucleus. Okay, this is the basic model. Now imagine these two isolated atoms are far away from each other. At that point they will not exert any of attractive or repulsive forces onto each other. But as they start coming closer to each other, what happens? The negatively charged electrons, as you can see here, the negatively charged electrons of this atom and the positively charged nucleus of this atom, they start to develop kind of attractions, right? Similarly, this positively charged nucleus and these negatively charged electrons, they will start to develop kind of attractive forces. So now as the attractive forces are increasing, just try to understand. I will draw a graph here which will give you very nice and crisp idea about how a molecule is formed, how a chemical bond is formed. Just look here. I will draw a graph where we will plot energy on the y-axis, and we will take distance between atoms, distance between isolated atoms on the x-axis. Okay, so from here I am starting out. This is a baseline I am considering. Okay, now this is from where we are starting out. These are the two isolated atoms. Now they are coming closer. As they start to come closer, as I told you, the attractive forces start to build. So because of the attractive forces, the system goes at lower energy level. So as the system starts to get lower and lower energy level, we can experience this kind of a graph. And then a point comes where the distance between two atoms is optimum and the interactions, the attractive interactions are maximum. Okay, this is that point. And then what happens? If the atoms try to come even more closer than that distance, then these electrons which are negatively charged, they start to develop kind of repulsive forces. And then these two nucleuses, they will also start to repel each other. Repulsive forces start to build up. So there is a specific distance, an optimum distance we may say, at the interactions or attractive forces are maximum and the repulsive forces are balanced. This is the point. Okay, if you try to force those atoms even close together, then what will happen? The repulsive forces will start to dominate, and then the system will go up the energy will increase like this. So this is how a graph of energy versus distance between atoms will look like, and this graph gives us this point here, and this point is nothing but the moment at which a chemical bond is formed. And a chemical bond is formed, I am going to tell you very important things, okay, pay attention. A chemical bond will form. See, any two atoms may approach each other, but every time chemical bond may or may not be formed. When it will be formed? When the atoms are approaching each other, if the energy of system decreases, then only a chemical bond is formed. Second thing which we have to consider here, that if there are two atoms but those are inert gases like noble gases, helium or neon or argon, and they are approaching each other, however you try, they are not going to form a chemical bond because their electronic configuration is stable. Their all atomic orbitals are completely filled. So a very basic requirement to be able to form a chemical bond is you need less electrons in your outermost shell. If your outermost shell is completely filled, then a chemical bond will not be formed. So it is the case with noble gases. They don't form any chemical bond, but other elements, they do form chemical bonds. They are reactive. Why? Because in their outermost shell, which we refer as valency shell, so in valency shell they have half-filled orbitals. They do not have completely filled orbitals, they have half-filled orbitals. And those half-filled orbitals, now imagine this atom has some half-filled orbitals, this atom has some half-filled orbitals, and they are approaching each other. Then they see an opportunity to complete their orbitals and get more stability. Then they say, why not? Let's form a chemical bond. And so they come closer, and at the optimum distance they bond with each other, and we call that they have formed a molecule. With a chemical bond, atoms join together to form a molecule. So this is how they are doing it. Now another thing, here we are talking about atomic orbitals, so I want to add something. Atomic orbitals which are in the inner shells do not participate in bond formation. In bond formation, only the atomic orbitals which are present in the outermost shell, which we call as valency shell, only they are relevant and they can participate in bond formation. Now such orbitals which are half-filled, valency shell orbitals, are referred as bonding orbitals. Okay, they are referred as, why they are not working? Bonding orbitals. Okay, half-filled orbitals, atomic orbitals in the outermost shell, they are called as bonding orbitals. Now the bonding orbital of one atom combines with the bonding orbital of another atom and they form a molecular orbital. This is how molecular orbitals are formed, and molecular orbitals are nothing but a chemical bond formed. So whenever a chemical bond is formed, bonding orbitals are combining together to form molecular orbitals. Now if you have understood this point, then let's jump into the types of chemical bonds. Now we have discussed how a chemical bond is formed. This is very important, how a chemical bond is formed. Now let's talk about what kind of chemical bond is possible. So let's start from ionic bond or electrovalent bond. So in ionic bonding, what happens? Let's take the same old example of NaCl, sodium chloride. Now in sodium chloride, what happens? Sodium, which has the electronic configuration of 281, means 1s2, this is the first shell, then in second shell 2s2 2p6, the second shell is complete, and in the third shell we have 3s1. This is the electronic configuration of sodium, 3s1. There is one electron in the outermost valency orbital, single electron is there. So half filled bonding orbital of sodium. And then there is chlorine. We know chlorine is 287. So what can be the configuration? 1s2, 2s2, 2p6, and for this 7, what we will do? 3s2, 3p5. Now this 3p5 can be split as this: 3px, 3py, and 3pz. And how we fill it? Like this: 1, 2, 3, 4, and 5. So as you can see, for chlorine, which is a 17, the unpaired or half filled orbital is 3pz orbital, and for sodium it is 3s1 orbital. So when they both will come closer, this 3s1 will be lost by sodium and it will be gained by chlorine. So this 3s1 will go here in the 3pz, and what it will form? A sodium isolated atom will form Na plus, because it lost one electron, Na plus. And what will be the configuration of Na plus? 2,8. Now this, do you identify this configuration? This is the configuration of a neon gas. So Na plus has achieved a stable noble gas configuration by forming Na plus ion. And then chlorine will form chloride ion, Cl minus ion. Why? Because it has gained one electron here. And what configuration it will achieve? 288. It is the configuration of argon gas, which is again an inert gas. So again, chlorine has acquired the configuration of a stable inert gas, argon. So obviously Na plus and Cl minus, by exchanging their electrons, by transfer of their electrons, they have achieved stable noble gas configurations. So this is how a chemical bond is formed in ionic category, right? We are actually talking about transfer of electrons to form ions, positively charged and negatively charged ions, and then they stay together because they have exchanged their electrons, they have transferred their electrons, they have been as ions, and ions, oppositely charged ions, they stay together because of the electrostatic forces of attraction. So this is a very strong kind of chemical bond which we call as ionic bond. Now let's start discussing how a covalent bond is formed and what are the different types of covalent bond. So I was telling you that when atomic orbitals, or when the bonding orbitals, they approach each other and they overlap each other, molecular orbitals are formed. Now how these molecular orbitals look like? So to understand this, you first have the idea about the shapes of atomic orbitals, and generally we do have an idea that s orbitals are spherical in shape, okay? Then p orbitals, they are dumbbell shaped like this. This is px, then there will be py, which is along the y-axis, and then there will be pz, which is, you know, at the right angle to px and py. So px will be like this, py and pz perpendicular to both of them. So p orbitals are like this. So let's talk about only these two shapes and let's understand how a covalent bond is formed. Now what happens if two atoms are approaching each other and they have half-filled bonding orbitals present? Then they have one s orbital with one half-filled, means one electron, one single electron is there. We are talking about s orbital. And then there is, you know, px orbital like this. So this is px orbital. Now both of them, they are approaching together. Px is also having one unpaired electron, s is also having one unpaired electron. They are half-filled bonding orbitals. So now when they both approach each other, what happens is these bonding orbitals overlap to form a molecular orbital. So how it will look? This p orbital will overlap into the s orbital like this, and they will form this sp bond means a bond where s orbital and p orbital of both atoms are overlapped in, end to end overlap. They are axially overlapping. There is end to end overlap. Another example I will give you. Suppose I am having one s orbital of one atom, another s orbital of another atom. Now they do not have any directional properties, s orbitals. So this s and this s, when they overlap each other, they will form a structure like this. You can see there is end to end overlap. There is axial overlap, right? This is how a sigma bond is formed. When there is complete overlap of two atomic orbitals, when they are aligned in such a way that they can overlap axially into each other, and they form a bond. If we draw a line on that bond, the electron density is well distributed around that axis, then that bond is called as sigma bond. Another example I can give you, a px and another px, they will also form a sigma bond. So for formation of a sigma bond, their alignment is equally important. They should be a px and a py of another atom. They will not form any sigma bond. They need to be in the same plane in order to axially overlap into each other. The end-to-end overlap must be possible directionally. So this is how a sigma bond is formed, like this. Sigma bond is formed. Okay, now let's talk about pi bond. Now how a pi bond is formed? Let's consider I am having a py orbital here and another atom is having a py orbital here, and both of them are having unpaired electrons. So half-filled py orbitals are approaching each other. Now as you can see, this is py, this is py, and they are approaching each other. Axial overlap is not possible. But when they are coming enough close to each other, as they are having single electrons, there might be a kind of attraction developed so that those electrons can be held together to form a chemical bond. So in that case, lateral overlap happens. This py and this py, they develop a lateral kind of force of attraction. Now as you can see, the py orbital has two lobes, one above the plane, one below the plane, and the electrons are free to move in any of these territories. So what happens is a pi bond is shown above the plane as well as below the plane, right? So this is how a lateral or side by side or sideways overlap is happening. Now as you can see, in a sigma bond there is actual axial overlap of properly aligned atomic orbitals. So basically the pair of electrons are held tightly. But in a pi bond, this is a pi bond, in a pi bond the orbitals are they are aligned vertically and the overlap is lateral. So the pi electrons, they are not that tightly held, and the energy wise if we are talking, then the energy of pi system is higher than the sigma system, because a sigma system is more stable than a pi system. So if in a molecule you want to check the reactivity of the molecule, then one molecule is having all sigma bonds, one is having pi bonds. We are talking about just the sigma and pi bond. There are multiple other factors which affect the chemical reactivity, but I am just giving you examples so that you will understand how the reactivity is affected by presence of sigma and pi bond. So if we are talking about only alkanes and alkenes, then alkenes will be far more reactive than alkanes because of the presence of pi bond, and pi bond offers, or they can be broken easily, so it makes the molecule reactive, right? Another point I want to discuss here, which is again very important. So in pi bond formation, you have seen that the py orbitals are laterally overlapping, right? So if I try to if I try to rotate any of the atoms, this is one atom with py, this is another atom with py, and they have formed the lateral overlap and they have formed a pi bond. If I try to rotate one of the atoms, it will distort the geometry, it will distort the alignment of py orbitals, and the bond will be broken. So we cannot allow rotation, free rotation of atoms when they are bonded in a pi bond system, and this gives rise to a very important property of double bonded compounds, which we call as Cis Trans Isomerism. Cis Trans Isomerism is actually existent because of this property of a double, means a pi bond. Means if you try to rotate the atoms along a pi bonded system, the molecule will break, right? So yeah, so I think we have covered almost all the good points related to how a chemical bond is formed, what kind of chemical bonds we can expect in a molecule, ionic bond and covalent bond, and what are the different types of covalent bonds, sigma bonds, pi bonds, what are the basic characteristics of a sigma and pi system, and what are any extra features for sigma and pi bonds in a molecule. I hope you have understood this point, and this point will be very crucial for your further understanding of organic chemistry concepts. So I hope to see you all in the next video, and till then, take care. Bye bye.